Okay, let's kick off this section with the first structural design pattern from the famous Gang of Four design patterns book. This pattern is called adapter pattern, and it's a pattern you use when connecting two incompatible objects together. I'll start with a quick summary of what we're trying to accomplish with this pattern. So, the adapter pattern is a good choice when you are trying to accomplish the following. You are converting the interface of one class into another interface that your client expects. Adapters let two classes work together that couldn't otherwise because of incompatible interfaces. You want to wrap an existing class with a new interface. Or you are trying to introduce an old legacy component into the system. Okay, let's go through the points one by one. The main issue here is that you have an off-the-shelf component that offers compelling functionality that you want to introduce in your application. But unfortunately, the component has a non-standard API that is completely incompatible with your application architecture. For example, you might be using data tables everywhere in your application to represent tabular data. You need the component to transform the data, but it can only read and write data using events. So the only way to hook this component into your architecture is by using an adapter, an object with a data table interface on one side and an event-based interface on the other. The adapter provides a kind of universal connector that hooks the two domains together. Another use case is when you are wrapping an existing class with a new interface. For example, you might have a class that contains a sequence of data, but that does not implement the IEnumerable interface. So, you will not be able to iterate over each item in the sequence with the for each statement. To fix this, you can create an adapter that wraps the class, provides a public IEnumerable interface, and uses the native API of the class to implement the enumeration. Finally, you can use adapters when introducing legacy components into a new system. A classic example is when using COM objects in .NET. COM stands for Component Object Model, and it is a C++-based object-oriented platform developed by Microsoft. The .NET framework contains a number of adapter classes that make a COM object look and behave exactly like a .NET component so that you can use them inside C# applications. The adapter pattern offers a very important benefit. Adapters greatly improve code reuse. Languages, platforms, and APIs change all the time, and due to incompatibilities, old but useful code is no longer in use today. 15 years ago, everybody was programming in C++ and COM. Today, C# and the .NET framework are the hot new game in town. And 15 years from now, we'll all be probably doing something different all over again. Adapters ensure that code written decades ago can still be useful in modern applications, and code written today can still be useful in 15 years. The COM COM/.NET adapter is a great example of this benefit. Because of this adapter, you can use decade-old COM objects in .NET applications today, even though the COM and .NET domains are utterly incompatible with each other. Another benefit of adapters is that you can reuse code across different platforms. Components specifically designed for one platform can be reconfigured to happily interoperate with another platform. This prevents you from having to reinvent the wheel every time and rewrite the component from scratch. Okay, here is the UML diagram of the adapter pattern. In the terminology of this pattern, we have a client object on the left, and it wants to make a request to an object on the right, which we will call the adaptee. Unfortunately, the client requires a specific interface which the adaptee does not implement, and therefore the two are unable to communicate with each other. To fix this problem, we are going to need an adapter that is both capable of communicating with the client and the adaptee. The pattern provides for this with an abstract base class and a concrete subclass. The target class is the abstract base class. It implements the required client interface, so it can be called by the client. But it also sets up an abstract request method which will call the adaptee and return the data. The adapter class is a concrete subclass that derives from target. It implements the abstract request method and contains code that directly calls into the adaptee class, gathers the data, and then returns it in a format that the client understands. Let me show you an example of the adapter pattern. I will implement a program that displays historic stock prices from popular tech companies like Apple, Microsoft, and Google. Now, let's pretend that I have a very cool financial database that contains the historic stock prices of many companies over a large range of years. But unfortunately, the database has a very specific interface. The stock prices are returned as arrays of decimal values, with each array item corresponding to the stock price in a particular month. Now, this doesn't help me at all, because my entire application is architected to use data tables for storing stock price history. I do not want to refactor my code to work with arrays. And I also don't want to edit the financial database. So that's the setup of my problem. I'm going to have to build an adapter to connect my application to the financial database. So I will implement the pattern with the following classes. Okay, let's take a look at the code. I'll start with the adaptee, which is called StockHistoryDB. You can see that it has three methods for returning stock data: get Apple, get MSFT, which is Microsoft, and get Goog, which stands for Google. These methods return 12 months of stock price history for Apple, Microsoft, and Google. The data is returned as a decimal array with the most recent stock price as the first item. This doesn't help my application at all, because it expects all stock data to be in the form of a data table. In fact, let's check out the target class to discover exactly what interface the client will need. So here is the target class, called Stock History Target. And you can see that it is an abstract class with a single method called getStockPrices. The method expects a single string argument which corresponds to the stock ticker symbol. It then returns a data table object with all 12 months of history. Let's take a look at the client class to see how it deals with the data. The client is called StockApp, and it has a method here called showStockHistory. The method expects a single string argument which corresponds to the stock ticker symbol. It then declares a variable of type stockHistoryTarget and initializes it with an instance of stockHistoryAdapter. The method then calls the target to retrieve the data table of stock history and uses this loop to display the historic stock prices on the console. You can see that the data table contains dates in the first column and the corresponding stock prices in the second column. Okay, so the only missing piece of this puzzle is the adapter class. It needs to bind the array-based interface of the StockHistoryDB class with the data table-based interface of the StockHistoryTarget class. And here is the StockHistoryAdapter class, where all the magic happens. The class is a subclass of StockHistoryTarget, and it implements the abstract getStockPrices method. You can see that the method uses a simple switch statement to retrieve the correct stock history, and then assembles the information into a new data table object and returns it. So this class is the actual adapter. It communicates with the client by implementing the getStockPrices method and returns a data table in the correct format that the client will understand. But internally, it communicates with the StockHistoryDB class by calling one of the stock history methods and retrieving the data as a decimal array. So this adapter effectively remaps the legacy interface into the new data table interface that the client understands. And this allows the StockApp class to communicate directly with the StockHistoryDB class. Okay, finally, let me show you the main program method. The code here simply creates a new StockApp instance and then uses the client to request the 12-month stock price history of the Apple stock. It then displays the historic stock prices on the console. Okay, let me run the program to prove to you that everything is working. I'm compiling the code now. And now I'm going to run the program. Here we go. And there you have it. 12 months of historic Apple stock prices. Everything works. Okay, here is a quick checklist you can use to implement the adapter pattern. First, identify all three actors in this pattern: the client, the adaptee, and the adapter. Then identify the interface that the client requires and put it in an abstract target class. Derive a concrete adapter class from the abstract target base class. Write the adapter code to map the client interface to the adaptee interface and place that code in the adapter class. Modify the client to use the adapter every time it needs to access the adaptee. And here are some final comments. In upcoming lectures, we are going to take a closer look at the bridge, decorator, facade, and proxy design patterns. These are all patterns for connecting two or more objects together, and the differences between adapter and these other four patterns can sometimes be a little confusing. So, here are some simple rules of thumb to help you distinguish between these patterns. Adapters make things work after they are designed. A bridge makes things work before they are designed. Adapters expose an alternate existing interface to a client. A proxy exposes the same interface, and a decorator exposes an enhanced interface. An adapter changes the interface of an existing object. A decorator enhances an object without changing its interface. A facade defines a new interface, whereas an adapter reuses an existing interface. Okay, so here is a summary of what we've learned in this lecture. The adapter design pattern changes the interface of an existing object to make it compatible with another object. The pattern improves code reusability because it allows components from alternate or legacy platforms to be used in your application. A practical example is the COM adapter in the .NET framework. The adapter pattern is part of a group of patterns for connecting objects together. It shares the group with the bridge, decorator, facade, and proxy patterns. Each pattern connects objects together in a different way.